Hey, welcome. We're going to be covering ellipses and circles today. And how does this rock? How does this go? Let's find out. Okay, you're going to determine how to the conic section form when a plane intersects. Hey, that was last time. The main one is we're going to talk about ellipses today. Here are ellipses. Got to get some parts. We do have an A and a B and a C part that we had last time, except it's a little bit different. So please pay attention to how this works. Notice here the difference between this side over here and this side over here. Obviously, hopefully you see that this one over here, the ellipse is going, the larger part of the ellipse. Okay, this is called here, if you want to, over here. We call that the major axis because it's the large one. So that means over here, this one here is my major axis. And guess what the short one's called? You're right, the minor axis. This one over here is the minor axis. Okay. So let's talk about the formula itself. Notice right here it has a squared here under the x's and a squared here under the y's. Why? Why did it change? The reason why it changed is because A, when you see it in your formula, is the larger number. And whichever one the larger number is on, that's where the major axis is going to be parallel to. So in this one, A is being the larger number, it's under the x, so my major axis is parallel to the x-axis. This one over here, A is my bigger number, which is underneath the y, which means my major axis is parallel to my y-axis. On the actual ellipse itself, the measurements are where A comes into play. A is the measurement from center to the major vertex. There's A. B is from center to the minor B. This part right here, this is the whole minor axis. This is the whole major axis. So that means over here, this is B, and this is A. Again, just this piece is B, and this whole piece is A. But what is C? I'm glad you asked. C is nowhere up here, but C is down here, and there's a relationship. This is not the Pythagorean theorem. C squared equals A squared minus B squared. C squared equals A squared minus B squared. C is the distance from the center to the foci. There's C. Okay, this part here, there's C. And it's going to be important for us in finding and graphing these and graphing all the parts to them. Okay, so let's go graph some, or actually graph one. So in graphing one, you just give us an equation. We got to pull this out. If I didn't mention before, our center is here. Same thing, you do the opposite. My center is equal to -2, comma, +1. You do the opposites, just like we've done all the time. And what I find out is which one's A. The bigger one is A, so in this case 9, but it's not just A. Remember, it's A squared is equal to 9. Okay, therefore A is equal to 3. The 4 is B squared is equal to 4, which is therefore B is equal to 2. And the last thing that we need is we need to know about C. C, remember, C squared is equal to A squared minus B squared, which means that this is that C squared is equal to 9 minus 4, which is equal to 5. Therefore, C is equal to square root of 5. And now I use all this information to graph my ellipse. Come over here. So first part, center, -2, 1. -2, 1. There's my center right there. And what then I got to do is I got to go and figure out, okay, A. So this means this is my major axis, which means X. So my major axis is going to be parallel to my X-axis. And this is going to take me to my vertex on my major axis. So I count over 1, 2, 3. There's that endpoint. 1, 2, 3. There's that endpoint. And those are those two vertex on the major axis. And then now I want to go ahead and do B, which gives me my minor one. Okay, there's 1. So up 1, up 2. There's that one. Down 1, down 2. There's that one. And there's my ellipse. And I can kind of make it. Kind of, sort of. Looks like a football. All right. And then what about my foci? Well, my foci are, okay, square root of 5 over. So square root of 5 is a little bit more than 2. So here I am, 1, 2, a little bit more. There's my foci. There's my foci number 1. And I go 1, 2, a little bit more. And there's the foci again right there. Okay, not bad. All right, it's not hard. You find an A, you find a B, you find a C, you start drawing things. How else can we do this? How else can we draw an ellipsis? But what if we only given characteristics, not the actual graph? Well, let's see how that changes things up. Ooh, write an equation for ellipse with a major axis and a minor axis. So they give us the points. So let's draw this out. So, here we go. Yeah. So here we go. So let's do my major axis is 5. So here we are. 1, 2, 3, 4, 5. -2. 1, 2. Here we go. And the other one's at -1. -2. So what does that tell me? That tells me that the A, this is my major axis, which is parallel to the x-axis, which means I'm going to use the formula x minus h squared over a squared minus y minus k squared all over b squared is equal to 1. So that's the one I'm going to use. Here's this length. All right. And so let's see if I can find my center from there. It's 6 across. 1, 2, 3, 4, 5, 6. So that means it's 3 is the center. I move 3 over. 1, 2, 3. Right there. What are the coordinates of my center? My center is at 2, -2. I found out just from here then that A is 1, 2, 3. A is equal to 3. Now let's worry about the other one. The other one says that my minor axis is at 2, 0, 2, 0, and at 2, -4. 1, 2, right here. So here my minor, the B part is 1, 2. So that means that B is equal to 2. Do I need to find C here? I'm just, all the equations ask me to find is the middle, or the equation. So now I have everything. So x minus 2 squared all over a squared. Well, a is 3. That means a squared is 9 minus y minus k. So here's the k. So it's -2. So it'll be y plus 2 all over b squared. B is 2. That's 4. 1. There's my equation. Not too difficult. Next one. Ooh, this one gets a little bit more difficult. This one says, write an equation for an ellipse with vertices at 3, -4 and 3, 6, and foci at 3, 4 and 3, -2. So let's go ahead and graph all this stuff here. So here we go, is graph. So 1, 2, 3, 1, 2, 3, 4. There's 1. 3, 6. 1, 2, 3, 6. 1, 2, 3. Well, way up here. Okay, and then foci at 3, 4. So foci is at 3, 4. There's 1 foci. And at 3, -2. All right. So what we should be able to see here is that since they didn't tell me that this is my major vertices or minor vertices, but since my foci are right here, I know that this line right here is my major axis. Since that's my major axis, I know that the a squared is going to be with the y's. Okay, equals 1. So let's go find our center. So if I count this up, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, there's 10 spaces. So I want halfway, which is just 1. Okay, halfway, which is just 5. So if I count up, 1, 2, 3, 4, 5, there is my center. My center is going to be at 3, 1. Now let's go ahead and find out our A and our B to get this done. So A is equal to center to vertex, 1, 2, 3, 4, 5. That's what we found out there. But what about B? Oh gosh, I don't have B. They don't give me a minor arc, but they tell me where my foci are. And my foci, from center to foci, I'm able to say, hey, 1, 2, 3, that's C. C is 3. So now I'm able to go ahead and find out what B is by doing that C squared is equal to A squared minus B squared. So 3 squared is 9 is equal to A squared, which is 25, minus a B squared. Subtract the 25, I get -16 is equal to a negative B squared. Divide by -1, take the square root. 4 is equal to B. Now I have everything I need. So I have your x minus h. H is right over here, 3 squared all over B. What's B? 4. 4 squared is 16 minus y minus k. K, here's the 1. That's on my center. Squared over A squared. What's A? A is 5. 5 squared is 25, which is all equal to 1. And there, my friends, is that equation. Oh, but wait, there's got to be another way we could possibly do this. No, I think those are going to be my 2 ways, or 2 things that you guys are going to be responsible for. The next thing that we're going to talk about, though, is what's called eccentricity. Not electricity, but eccentricity. What eccentricity is, okay, is if I have my ellipse, doesn't matter which one it is, I'm going to write this out bigger so that you can see it. E is equal to whatever C is divided by A. Again, remember A is the larger one, is the length of half of my major axis. But what is eccentricity? Eccentricity is how oval it looks, or how circle it looks. Because if here's a fun thing, if A is equal to B, then the ellipse is no longer an ellipse. the ellipse is a circle. Okay. And the eccentricity C part is that the closer E is to 0, the more circle-ish it looks, the rounder it looks. The bigger the number, the more oval the ellipse looks. The smaller the number, the rounder it looks. So, how do I find eccentricity? Great question. Let's go take a look at what we can do. It says determine the eccentricity of this ellipse. There's that ellipse. Okay. Again, I need an eccentricity. Well, fine. That's going to be C over A. Alright, well, the eccentricity, C over A. Well, what is A? Which one's A? A is the big one. So this here is equal to A squared. This one here is B squared. So A is easy. A is 8. I don't care about what B is, but I do need to find C. And remember, that's the relationship that C squared is equal to A squared minus B squared. C squared is equal to 64 minus a 36. So, (64 minus 36) is equal to 28. C is equal to the square root of 28. And now I'm able to say that my eccentricity is equal to the square root of 28 over 8. That's it. It's about as easy as it gets. It's all about formulas. You just have to know your formulas and know which one they're talking about. Last one is using an eccentricity to find out information about our ellipse. So they say here the eccentricity of an orbit of Uranus is 0.47. Its orbit around the Sun has a major axis length of 38.36. Let's kind of draw this out. Here's my ellipse of Uranus going around. Okay, so we'll draw, there's my big giant planet. There's the ellipse of its orbit. Here's the center. It's saying this whole distance, this whole thing, is 38.36 atomic units. An atomic unit, just so you know, is how much distance it is from the Sun to Earth. Okay, so this is 38 times from the Sun to Earth is how wide it is on the ellipse. What is the length of the minor axis of the orbit? So it's wanting to find out this. That's the question mark. Well, let's find out how we can figure this out. They give us a little bit of clues, though. All right. They say that E is equal to 0.47. What did we just get done talking about? E is equal to C over A. All right. So if E is equal to C over A, well, do I know C or A? Well, okay. This whole distance is 38.36. I don't want the whole distance because remember A is just this distance from the center to here, which is half. So that's A. So 38.36 divided by 2 means that A is equal to 19.18. I put that into my formula. 0.47 is equal to C over 19.18. Multiply both sides by 19.18. I get 9.01 is equal to, or 0.14, excuse me, is equal to C. Well, how can I find out B if I know C and A? Oh yeah, that whole C squared is equal to A squared minus B squared. That relationship in the ellipse. Well, I know what C is. All right, so and C squared. Okay. And 19.18 squared for A is 367.87. So A squared is equal to 367.87. And now it's a plug and chug. All right. So we do 81.26 minus 367.87. And divide both sides by -1. And I get that B squared is equal to 286.61. Take the square root of both sides. And I get that B is equal to 16.95. Am I done? Not quite. Why? Because this is B, just that piece. When they ask for the length of the minor axis, it's asking for the whole thing. So I multiply that by 2, multiply B times 2, and I find out that that axis is 33.85. So B, actually, the minor axis is 33.85 atomic units. Ta-da! Done. When you guys get in, you guys will have a worksheet, and you'll be able to work through that. Should be just a day. Talk to you guys later. Bye.